Last episode, I told you the model figures out token prediction by reading enormous amounts of text, trillions of times. Now let's look at what figuring it out actually means. It's called training, and it's stranger than you might think. Imagine teaching someone a language without ever defining a word. You just show them billions of sentences with one word missing and ask them to guess. They guess wrong. You tell them the right answer. They guess again. Wrong. Right answer. Again. And again. And again. That's training at a wildly large scale. Here's the loop. The model takes a stretch of text. It sees the tokens so far and predicts the next token. Then it compares that prediction to the real next token in the original text. The difference becomes a wrongness score. The model adjusts its internal numbers, billions of them, slightly, so the same kind of guess would be a tiny bit less wrong next time. Repeat that loop trillions of times on text from books, articles, code, web pages, and other sources the lab can access. No human writes those rules by hand. The patterns are learned from the loop. Slowly, the model's internal numbers, sometimes called weights or parameters, settle into patterns. Patterns for grammar, for simple arithmetic, for sarcasm, for Python syntax, for the structure of an essay. None of these were programmed. They were implied by the data. This phase is called pre-training, and it's where most of the cost goes. Modern frontier models reportedly train on hundreds of billions to trillions of tokens, on specialized hardware, for weeks to months at a time. But pre-training alone doesn't give you something you'd want to talk to. A pre-trained model just predicts next tokens, including ones that are toxic, unhelpful, or factually wrong, if those patterns existed in the data. So labs add a second phase, often called fine-tuning or instruction tuning or alignment. Humans review the model's outputs and rank them. Better answer? Higher score. Worse answer? Lower score. The model adjusts again, this time to produce the kinds of outputs humans rated as good. Different labs do this differently, but the broad shape is similar. Pre-train on raw data, then refine on human feedback. Now, there's a difference between training and using. Training is the expensive part, adjusting billions of internal numbers to match patterns in massive amounts of text. Using the model is much cheaper, just running your input through those fixed weights and getting predictions back. Once a model ships, every conversation you have is the using phase, not the training phase. Which means, once a model is trained and shipped, its weights are frozen. The underlying model doesn't learn new facts from your conversation. The product may store memories about you if memory is turned on, but that's different from changing the model's weights. That's also why models have a knowledge cutoff date. To recap, training is iterative. Guess, correct, adjust, repeat. Pre-training shapes raw competence, fine-tuning shapes behavior. There is no neutral training run, and once shipped, the weights are frozen. The model doesn't learn from you in real time. Next episode, we'll look at how the model handles your conversation, given that it can't actually learn during it. The trick has a name, the context window. If this was useful, subscribe. It tells me to keep making them. See you next episode.